Good morning, everybody. I'm sorry. Good evening, everybody. It's Naveen joining the call. Can you guys hear me? Could you please type in the chat window if you can hear me fine, guys?
Good evening, sir. We can hear you.
Okay, great. Thank you. Sorry about the delay, guys. As indicated, it's the end of the year, and this is the time when we have a lot of workload. So some of the things are this week. Generally, it is the last 2 weeks of our year is generally like this. So just bear with me. Without much further ado, let's go ahead and get started, guys. So yesterday we talked a little bit about Numpy arrays. We'll continue our journey. We'll try to understand. Today, I will try to increase the complexity a little bit, and we'll try to get into some of the practical aspects of Numpy that we have discussed yesterday, guys. That is going to be the plan, guys. Yesterday, we have looked at creating a Numpy array, and we have tried to perform some arithmetic operations, and we have looked at that. So, come back here. There's a Jupyter Notebook. Remember, Jupyter Notebook is a web ID, and let's see what we have here. Here is underscore array 1D, which is a Numpy array. This is how we created Numpy array. So let's say one more time for the sake of discipline. Let's come back to start with the list. Remember, list is an object which is a group of items where you can have numeric data or textual data. For the sake of simplicity, we'll go ahead and create a list object like this, and then we'll convert it to an array. And here is how we convert it to an array. And what is special about array is it can contain only numerical data or textual data. But what is more special, what is more important is we can perform arithmetic operations. Okay, so take an array, which is like a group of items, like a tray, and you do a +2. What's happening is the 2 is getting added to this element, that becomes a 2. 2 plus 1 becomes a 3, and so on. These are referred as element by element wise operations, matrix like operations back in school. And just a quick refresh there, guys. We can perform multiplication, we can perform subtraction, we can perform division. Everybody with me, guys? Quick yes, please. Okay, thank you. So now let's increase the complexity a little bit. Come here, take a look at this. This is where we were yesterday. Here's NP. NP, if you recall, is a friendly name of Numpy. Numpy is a package for arrays and matrices. That's Python does not have arrays and matrices. Numpy provides you the arrays and matrices, guys. So what is zeros? Zeros is a function in that package. What is happening? We're creating 5 objects. That's what that does, and it's filling up zeros. That's what zeros does. Similarly, there is another function called once. Pardon me. Take a look at this. There is once, and what is it doing? Well, it's filling up a tray and putting 5 ones inside that. Okay, now if you try to do something like twos, notice you don't have twos. It'll give you an error if you try to do twos, threes, and things like that. If you really want twos, what you can do is you can say numpy.once multiplied by 2. That can give you a 2. So all the ones are getting multiplied by 2, and if you want 3s, 4s, and things like that, you can do the multiplication. What happens is a vectorized operation is happening inside, guys. And let's see, so the 3. Now take a look at this, guys. What is this? This is like one dimension. This is one dimensional array. Now we'll increase it to 2 dimensions. Here is np.zeros 2. So that's going to be 2 rows and 2 columns. It acts like 2 rows and 2 columns. What are we doing? It's filling up zeros. That is what. Why do we have only zeros and ones and not 2s, 3s, and 4s? Because zeros and ones are binary. If you go deep inside to the computer can only understand the ones and zeros and things like that, guys. So that's why we have a special function for zeros and ones. Based on them, we try to customize them, and we try to create other things. So there is again np.once. This time we are creating a 2-dimensional array that is referred as a matrix. Okay, so we're adding 1 dimension as what this is doing, guys. Now come here, again repeat this, np.once 2 by 2. What is this? This is creating a matrix with all of them as 2s. A 2 is getting multiplied with everything. Again, like an element by element wise operation, guys. One more time, quick yes please, everybody with me. They are binary. Zeros and ones are binary. That is true, guys. So let's see. Come here again. Take a look at this. Adding one more dimension, not dimension, but the number of columns. It looks like. So it's like 2 rows and 3 columns, kind of. 2 rows and 3 columns is what this is. So we can go ahead and create as many ones as we need. Based on our requirements, we will do that, guys. Now notice another one, a slight variation here, which will do a similar thing as the above, which is matrix. You can also use a function called matrix. And what are you doing? You're kind of giving like a list object, or think of it this like an array object. You give a one dimensional, you give it a matrix. What does it do? It will convert it to 2 dimensions. It will convert it to 2 dimensions is what is happening. Okay, guys, that's what the matrix does. Matrix is directly creating it in 2 dimensions. And again, let's create another matrix here. So let's say it is 4, 5, 6. And let's see what we can do with it, guys. Now take a look at this. Let's see, come back here. Applying this one. So visualize, we created something like this. Here is, let's say 1 and 2. And here is 3 and 4. We'll call them as 2 trays. What do we have? These are cups here. And what's this? This whole thing is in a big tray. This is what is happening. This is like a tray of 2 trays. That is what is 2 by 2. Next we'll also repeat the same thing. 3, let's see, we created, what did we do? 1, 2, 3, my bad. Sorry guys, I'm still in 1 dimension. So let me come back here. Let's say here is 1, here is 2, here is 3. That's a tray. Those are the cups for the cups are like the objects. And this whole thing is inside a tray. So this is a tray of a single tray with 3 cups is what is happening. Then we have 4, 5, 6, another tray. So let's say, choose this one. Here's a 4 and a 5 and a 6. Put them in the cups. Put them in a tray. And that becomes a tray. This is 2-dimensional tray. Now, notice this, guys. What we are doing is, we will do what is called a head stack. Head stack is a function. We're giving these 2 trays. Pardon me. So this is what is happening. We get 1, 2, 3, 4, 5, 6. Let's try to visualize this. So imagine something like this is happening. What it is doing is, it is head stack horizontal, H for horizontals. So it puts 1 here, then puts 2 here, horizontally, then put 3 here. Okay, then put 4 here, then put 5 here, then put 6 here. And what is this? Put all of them, let's say come here, put all of them in a single tray, then put that in a set a tray. What do you have? Here, again, what are we doing? We're doing cut and paste. But what's happening? It's actually doing a copy and a paste. This is one way to visualize it. Everybody, guys, can you give me a quick yes, please? We are stacking them horizontally is one way to think of it, guys. Let's say, how about another way, guys? Take a look at this. Visualize, put them back to the original. Now visualize something like this is happening. For a moment, you take the item here, which is the tray here. You take this tray, put them horizontally. Okay, what do you do? Make them as one tray. And now what do you do? Put that into another tray. So that's a tray of a tray. What do you have? Ideally, you have 6 cups in them. That is another way to visualize. Just visualize as you put the tray, these three are being plugged on the left hand side. These 3 are being put on the right hand side. And together, those 2 are being made one tray and they're put into another tray. That is head stack. Okay, let's also take a look at what is V stack. Here. Look at this. Here's V stack. Now what is happening? It looks like this, guys. Let's go back here. Let's try to visualize this. Now what is V stack, guys? In a way, in a simple way, think of as if it is taking the first item here. Think as if it is taking the second item here. And then what do you do? Put them in a tray. So what's happening? There's 1, 2 and a 3 here. There's 4, 5 and a 6 here. That's what is happening. It is putting the 2 items vertically. So notice, it is kind of like sitting on the top. It is kind of like sitting the below that is what it is. That is called V stack. V stands for vertical is what it stands for. Everybody with me? Quick yes, please. Okay, then let's go a little ahead. You might be wondering, why we are learning this kind of functions, and because later we'll come across some of these functions and things like that coming up days, and it will be helpful if you have an idea of these guys. So think of these things as the basics, but we are slightly in a slight stage of NumPy. Let's repeat this one. Now take a look at this, increasing the complexity. We're going to add one more dimension, which is a matrix, which is a tray of trays or a two-dimensional array. So let's take a look at how this looks like. Come here. This here. That's a two-dimensional tray. So back here, blanket. Say come here. So there is 1, there is 2. Visualize, that's in a tray. Here's a 3, here's a 4, there's a tray. Okay, what are we doing? Visualize, this whole thing is in a tray. Okay, then come back here. Here's another two-dimensional tray. This is going to be 5, 6, 7, 8. There it is. It looks like that. That's a tray of 2 trays or double-dimensional array. Let's visualize that. 5, 6, 7, 8. Visualize the cups as the objects for sake of simplicity. So put that into another tray. Now let's repeat the process. Come here. We'll start with okay. And one moment. Let's come here. Sorry about that, guys. So now let's see. This is how head stack looks like, guys. So what happened here? Let's come here. We'll on. How about this one, guys? Let's say, for sake of simplicity, I'll put this here. We are taking the first item. In this pink tray, the first item is this tray. You're taking this item. For sake of simplicity, let's give this a blue. Let's give them green. Let's give this pink. And let's give this a yellow. So if you take the pink tray, the first item in this is not the cups, but it is a blue tray. This becomes the first item. And what are you doing? You pick up the first item from here. Put both of them here. Now what do? Let's make them 1. They become one tray. So what is that? That is 1, 2, 5, 6 are kind of sitting here. 1, 2, 5, 6, just visualize there, coming there. Then come here, pick up the second item here. Pick up the second item here and put it horizontally. Horizontal stacking, head stack. So what do? Well, come here. We'll change this to yellow. So that becomes that. And now you visualize 3, 4, 7, 8 are coming here. What are we doing? We are now, let's say, take this one, or let's say take this one, put them in another tray. That's what makes it two-dimensional. So what is that? That's like an array of 2 arrays is what is happening. And everybody with me, guys, are you able to catch that? Quick yes, please. Okay, let's also go one step ahead. We'll repeat this on a V stack. What it looks like. Pardon me. Take a look at this. That's how it looks like. So if you come back here, take their original places. So now take the first item here, put it vertically. What it is doing is, it is not going to the second one, it is coming in the right tray, putting this here. Then put this here. And again, take the next one, put this here. Now what do? Put the whole thing in one tray. That's like a tray of 4 trays. So notice, 1, 2 is the first one, blue color, this is the green one, this is the pink one, this is the yellow one. They are being stacked vertically. Everybody with me, guys. Quick yes, please. So let's come down and see what else we have. Let's increase the complexity, guys. Okay, kind of take you to a slightly few more combinations here. So let's start with this one. Now take a look at range. We haven't talked much about range, but let's see if we can understand a little bit. Here is x. Now if you see what is x, notice it gives you from 0 to 9. What's happening is, range you visualize as if It is printing the numbers from 0 to 99. 100 is exclusive. It is not inclusive. Yesterday we talked a few mantras, inclusive and exclusive. We'll again touch them today from a practical perspective, guys. Okay. So for now, think of range as kind of giving you 100 numbers. How? In a tray, in an array. In other words, think of this as giving you a list. It is converting it to an array. Okay. Arrays, remember, compared to lists, are fast. They're super fast. Speed. That is what is the advantage of arrays. That's why everything in terms of array. Following an array-oriented, Numpy gives us an array-oriented language. The main is the speed, guys. Imagine that is about 100 is what we have. Then let's see. Come back here. Let's take a look at ndim. Ndim. What this is? This is telling you this is one dimension. What is one dimension? This is like a single dimension. If you have one bracket, that's like single dimension. If you say shape, hold on here, it will tell you, it's telling you, it's kind of saying there are 100 items inside it. It actually gives the rows and columns, so it is taking this as 100 rows, one column is what it is, guys. You'll better understand shape when we look at a two-dimensional moment. But take a look at size. Size is counting how many objects are there in that container. 100 objects, 100 cups in a tray. That is what is size. Then come and look at D type. It is like type. It tells you int32. Int32 means they are decimals. Range is giving you non-decimals, not decimal values is what it is. These are some of the basic functions. Everybody with me? Can you give me a quick yes, please? Even numbers. If you want even numbers, we need to write some customized for loops and things like that, which is not difficult. Maybe I'll show you in the coming up days when I touch a little bit of for loops, guys. But it is possible. But let's try to focus on some things we'll be touching. So now let's increase the complexity. Take a look at this. Here is np.array. What we are doing is now we have an array of arrays, two-dimensional. Okay, so let's say take a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's take a look at how y looks like. Now, gentlemen, ladies, if you take a look at this one slightly carefully, it's probably a slightly confusing and a tough question. There is something special about this array, guys. Can any one of you type in what could be special about this one? What's special about this array? 1.0. It is two-dimensional, but notice everything has a 1 dot. If it is 1.0, Python just shows you as 1 dot. It's saving some space and things like that for printing. If it's 1.1, it will show you 1.1, but if it's a 1.0, it just shows you 1 dot. It is telling you it is not, it's a decimal. It's treating it as a decimal. But if you take a very close look at this one, there is a reason why it is now treating everything as a decimal and not as a non-decimal. Let's see if any one of you can why is it treating it as a float Bharat? Why is it not treating it as an integer? Take another look at this array. Is there something there which is making it treat it? There you go. 1.0. One of the elements we plugged in it as a decimal. So it is treating everything as a decimal. That's why you're seeing it dot, 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 and so on. So that's a small thing, a subtle thing just to be aware of. Small things and so on. But let's focus on more. Now you ask it, hey, what is dimensions? What is the number of dimensions? So take a look at this. 2. It's a double dimension. It's like a tray which has 3 trays. An array of arrays. An array of 3 arrays is what is happening with 3 cups in each array. 3 objects in each array. So that's called 2 dimensions, guys. Let's see what else we have. Now, what is the shape? What it gives? It should be 3, I think. 3 by 3, my bad. Let's see what's happening, guys. So what's happening is, it's treating as 3 rows. I'm sorry. That is 3 rows there and 3 columns. That is what shape is telling you. Okay. And dim is giving you 2 dimensions. So dimensions is 2, shape is, it's saying roughly there are 3 rows there and each row has 3 cups, 3 objects or 3 columns. That is what is shape. 3 rows and 3 columns. It's treating it like 3. Now if you ask it, hey, what is the size? We are saying, hey, we're asking it how many objects are there inside you. It's counting and saying there are 9 of them. Look at that. 3 plus 3, 6 plus 3, 9. Okay. Then the last one, you ask it data type, and now it gives you a float, not an integer. because one of them at the time of creating the integer, we plugged in it as a decimal. It's treating everything as a decimal. Everybody with me, guys? Quick. So if one of the elements in matrix, is in decimal, it's treating everything as a decimal. Now you may ask me why, but more than understanding why, that's how it's working. Let's take it that one, and we'll be able to build more on that, guys. Okay. So let's take a look at a few more examples. Let's see what else. Now this, guys, another big one here. P.full function. Commonly, we will come across this. Take a look at this. Full is a function. What it is doing is it is creating 5 rows, 5 columns. It's putting 53, filling up a value 53, 53, and 53, and that is what it is doing. It's filling full values or all the elements with 53, 5 rows and 5 columns. Okay, guys. We don't need to by heart, but the next time you see it, I'd just like you to be familiar with that, guys. Huh? Let's come back to our original array X. Let's see what we have. There is X. So it's like a tray of 2 trays, is what I call in a friendly way. The technical mantra is it's a double dimensional array. It's like a matrix. Okay. Now let's see what happens here. Take a look at this, guys. Increasing the complexity now. Say, pardon me, np.full. Notice what is happening is x.shape. What is x.shape? The shape will be 3 rows. 2 rows. This is going to act like 1 row. This is going to be acting like the second row. 3 columns, 2 by 3. So what we are now doing is we are saying to the function full, take 2 rows and 3 columns. Take the 2 rows and 3 columns. So what the shape is doing is it's looking at this matrix, understanding there are 2 rows and 3 columns, and it's filling up with 53. Okay, so instead of manually hard coding the values, those things, or here, instead of hard coding the number of rows and columns, what we are doing is we are dynamic from that matrix. Are you able to understand? Yes, that's a slightly deep one there. Shape of 5 by 5. We'll say this as m1 equals to np.full, and let's say m1.shape, that should give you 5. Pardon me. Okay, guys. Somebody was asking that, so I quickly typed in that. But let's see. More little ahead, guys. Now take a look at this, guys. np.I. Pardon me. Yeah. np.I. Notice what's happening. If you take a look at the diagonal, they're all filled up with, the diagonals are filled up with 1. That's what like a diagonal matrix, what do we call that? Identity matrix. Back to school and things like that. Identity matrix. So all the diagonal elements are 1. Let's take another look at 5 by 3. Let's see how that looks. If you just give 5, notice it created 5 rows and 5 columns. But here we're saying I want 5 rows and 3 columns. So what happened? It took the first 3. It took the diagonals and it plugged in 1, and the rest of them it's not working. Now why is it working? We need not worry about that. More importantly, that is how it is working. Ideally, when we use I, we will use it in a much more uniform way, like that, rather than like that, guys. That's generally what happens. It's something to be familiar with. Now take a look at this, guys. Back to range of 90. It is like, it's going to give you numbers from 0 to 89. 90 is exclusive. You're going to build an array, and you're going to call that as next. So you should see 0 to 89. Okay, then come here, x.reshape. What are we doing? 10 rows. We're kind of saying I want 10 rows and 9 columns. X.reshape. So you're asking that array, reshape it. So what happened here? This is like a single dimension. A tray of 90 cups here has become a tray of 10 trays. It's a double dimensional, an array of 10 arrays where each array has 9 cups. 0 to 8 is 9. 9 objects in each tray. So what is reshape doing? Reshape is generally used to add one dimension. We say we converted a single dimension to another dimension. We have added one dimension. Everybody catching it, guys? Can you give me a quick yes? Why is the matrix taking float? It's not taking the float. It's taking integer. This is not 0 dot. This is 0 comma. If that is what, okay. I think you were referring here. I think somebody was asking me why is it no, I don't. I exactly don't know. why it's taking a float there. That is how it is working as. That's a good question, maybe a tough question, but I'll skip it. It's it's more of a computer science standpoint, but forgive me, guys. I don't really know why it's taking that one. But let's move on, guys. Let's take a look at this now. What are we doing? You go back to the X, which is like a array, a single dimension array. What we are saying is, give me 3 rows, 3 columns, and 10 objects. So let's see what happens here. Let's run it. So there it is, guys. Wow. Okay, 3. That became a 3 My bad. This is going to be slightly tough one for me to explain, but let me give a try. That's like almost became a 3 dimensions there. Reshape. Okay. And what did it do? 3 by 3. So it created 3. It's more precisely creating a 3-dimensional thing here, guys. There's a 3-dimensional thing going here. 30 objects or 30 cups went in there. The next 30 went in there. And the next 30 went in there. Okay, so in other words, okay, so what is happening is, so actually, for a moment, where I got confused was, I thought it was actually 1-dimensional array which got converted into that one. But what we did was, we did this one. We took a 2-dimension and then we did a reshape into 3 by 3. So a 2-dimension has become a 3-dimension. Reshape has added 1 dimension is what it is. It converted a 2-dimension to a 3-dimension. So indirectly you can say where reshape is used for adding 1 more dimension. And what is it doing is, it is adjusting the number of objects here. Okay guys, that's a slightly deep one. 3 rows, 3 columns, 10 elements in each row, that is true. But are you getting a catch of that, guys? Okay, so we have few more things to go on, guys. Try your best in following. And if I keep repeating the same thing, there's a better, I will ask you for a better attention, guys. So just stick with me. Okay, so it looks like reshape is adding 1 more dimension. Is a short way to remember. Now take a look at this. Back to the original. That will give you a 1-dimension array. Now what you're doing is convert it to 10 by 3 and 3. Okay, let's see how that looks like, guys. So that's going to be, come here. There it is. Tough one, guys. Okay, what happened again? It converted into 3 dimensions. That's a 3-dimensional thing. So what's happening? From a single dimension here, this is like a single dimension. It converted into 3 dimensions, and there are 10 of them. All the 90 objects are getting plugged in. There is probably a better way, more easy way for me to explain, but for now, I will leave a little bit of complexity here and say, hey, it's creating 10 of them with 3 by 3 is what is going on. That's even I need a little bit of time explaining that one and simplifying a bit further, guys. But let's see. Now take a look at this, guys. What is this one? This is a 3-dimensional array. Now what we are going to do is, we say x dot ravel. If we say x dot ravel, notice what happens. It got converted into single dimension. What is ravel? Ravel is like, it is converting, it is lowering the number of dimensions. A 3-dimensional array has been converted into 1-dimensional array, that is called ravel. Okay, what are all these functions, guys? If you go into the world of Java and .NET, these are all big programs. What you're using in a single function, you'll write a code for maybe 10, 15 or maybe 20 lines of code for every small thing. Here everything is given as a function. You'll probably take 1.5 months to write this kind of functions, this kind of programs in Java and .NET. What we are doing is, we're almost kind of in the beginning, in the first week of Python, and we're already seeing, what is this? This is reshaping. Okay, we're adding a dimension, reducing a dimension. This is the Numpy way. This is an array, kind of an array-oriented way of thinking. Okay, and everybody okay with Ravel, guys? Can you give me a quick yes? Converts multi-dimension into single dimension. That is true. Okay, guys, take a look at this. Back to np.array. This will create one array of 90 objects. 10 3 by 3. Again, we're repeating this one. Let's see what happens here. Back to here. Let's run it. So take a look at this. That is again 10 3 by 3. Now what we are doing is again T for transpose. Let's see how that looks like, guys. 3-dimensional if you transpose it. So now, earlier we had, each array had 3 objects or 3 cups. Now each array has 10 cups here, roughly 10 cups, and it converted into 3. So another way to understand this is if you say x.t.shape, you're getting 3 by 3 by 10. What was 10 by 10, 33 has converted to 3 by 3, 10. Okay, guys? Okay. Everybody with me, guys? Can you give me a quick yes on transpose? That should be a pretty straightforward one. Okay. Let's move a little ahead and see what we have. Range. Back to range. The mantra, inclusive versus exclusive. Left-hand index is inclusive, right-hand index is exclusive, comes back. We're converting it to an array. So let's see what happens here. There is 1. We start with 1. We go to 100. 101 is exclusive. What is this? This is a single dimensional array. Okay, now come here. What do we do? X dot sum. So what do we get? What sum is doing is it's taking all the objects, summing them up, as simple as that. You can also do x dot min. You'll find the minimum value. You can say x dot max. And the maximum value you can say x dot mean. Taking the average of all the numbers from 1 to 100, you can say x dot sd. Give you the std dev, I think. Std dev. Oh, sorry. How about this one? I'm sorry. Okay, what we can do? Do a dot, do a tab. It will give you all the functions. And let's type in std. There you go. std. Connect. That's the standard deviation. Okay, so what are these? These are all the functions which are built into arrays. These functions are built into arrays. That is what is special here, guys. You can also calculate the median. We briefly discussed. Now take a look at this. You're taking an array. You're using median as a function. You can also say np.mean. These are in Numpy. What did we do here? Here you're saying x.mean. Okay, the array is also giving you a function, more precisely a method is what it is called, guys. But for now we'll call this as a function. We can either use it like this, or you can explicitly use a function which is in Numpy like that. Everybody catching it, guys? That's a slightly deep one, but at a high level we can do both of them. In other words, a more simple answer is arrays have all these functions built in and you can call them directly. That is a convenience, guys, more precisely. np.square root. Again, now take a look at this, guys. np.square root. Here is x. X is a group of numbers from 1 to 100. Now, if you say np.square root, notice what is happening is square root of 1 is 1. Square root of 2 is 1.414. Square root of 3 is 1.732. Back to school. So what's happening is it's taking each number, and what is it doing? It is calculating the square root of each number. That's what is happening. When you do a mean, a median, and things like that, it's taking all these objects and giving you one. So many objects are giving you one object. But when you do a square root, what's happening? Many objects are giving many objects. This is like many to many. Also, many to many relationship is what is happening, guys. But let's see what is happening here. Take a look at this. Back to range of 100, 0 to 99, 10 rows, 10 columns. Let's see how that looks like. There it is. 0 to 99, 100 is exclusive. Okay, and created a double dimensional array. And let's see, now take a look at this, guys. Slicing and dicing. Python is super powerful here. x01. So it's like you're saying, remember Python is following a zero based index. So you're saying, hey, give me in the first array, first tray, give me the second cup. What is that? In the first array, give me the second cup is the second object is going to be that one. So that is that one. When you try to get one object, this is called indexing. You're only extracting one object from here. So this is like saying third tray, give me the 9, which means 10th cup. So let's say, here, there it is, 29. So here is the third tray or third array, and there is the 10th cup. 9 means 10. Okay, guys, here we're getting one cup at one time. Okay, but take a look at this. x of 1. You're asking this double dimensional tray, give me 1. It is you're asking for the second tray completely. It's like saying, give me the second tray, all cups or all objects inside. Second array with all objects, that is what. If you only give 1, it is treating that as a row. Now we are getting a group of objects. This is called slicing and dicing. Now take a look at this, guys. What we are doing is you're saying, give me all the rows. Give me 2 means 3, the third column. So let's see what happens here. Come here. Take a look at that. So 2, 12, 22 and things like, what is this one? Take a look at this. Here is 2, here is 12, here is 22. So it's kind of extracting this from here. All the rows. So it's going to every row, picking up the third cup, third cup, third cup and things like that. Everybody with me, guys. Quick yes, please. Inclusive and exclusive. Yes, here is also the mantra is the left hand side. If you just give a colon, you didn't give anything, which means it's acting like a star, which means all the rows. The left hand side part of it is describing the rows part of it, what you want to extract in rows. The right hand side part of it is 2 is 3. Okay, I see what you mean by exclusive. So here they're specifically asking us, the exclusive is not being applied here. It is actually including the right hand side part of it. Good one. If you don't have this one, if you just had a colon like that, then I think this will become exclusive. So let me try to run that. So now notice 2 is 3, but it is only giving you the first row and the second row. Now it is acting like that part is exclusive. If you put a comma, that exclusive mantra is not coming into the picture. You all catching it, guys? Okay, so what I'm asking you is, you don't by heart, you be familiar. We'll use this kind of concepts in the coming up ones, so I'm trying to get you familiar, guys. Don't worry about by hearting. So now again, this is where the mantra of inclusive and exclusive will come into picture. 1 colon 3 means it's like 2, 3 and 4. So what will happen? 1 is inclusive, 1 will be 2, 3 will be 4. So you're asking it, give me the 2 and second and the third rows. Okay? Second and the third rows. You're not getting the first and the 2. So inclusive and exclusive acts here. Now you're saying, give me all the rows and the right hand side. Whatever is on the right hand side of the comma describes the columns part of it. So now you're saying second and third column. So this will extract all the rows, second and third column. Here it is. 1, 11, 21, 2, 22 and so on. So if you come back here, so notice the first column is 0, 10, 20, 30, 40. The multiples of 10 got ignored. It picked up this one, it picked up this one. In other words, just for the sake of discipline, I'll quickly show you what's happening here. Choose this one. Out of all that thing, we have extracted these columns. This is called slicing and dicing. How are we doing that, guys? We are doing that using, so let's say, come here, using one single word. What you write 50, maybe 20 lines of program in a Java or .NET, one line of code is extracting it. That is what is called the simplicity of Python. Everybody with me, guys? Quick yes, please. Okay, at a syntactical level, it is very simple. But what is complex is, this kind of thinking is slightly complex. It is not complex. It is something you need to practice and just be familiar. In various parts of Python programs, you will see this kind of code coming in. You need this kind of array-oriented thinking is what is expected of you guys. Can you do x dot square root? I don't think so. Square root will not be meaningful, short answer. But now come back here, guys. Take a look at this. This time we are saying, give me, this will end up being, give me, you're asking, give me the second and the third row and the second and the third column. So let's try that. Yeah. So there it is. Which means, if we come back here, if we undo this, the second and the third rows will be these two. In the second and the third rows, what are you doing? You're further extracting the second and the third columns. That's what we are extracting, the green part, slicing and dicing. Okay, so in other words, in a slightly friendly way, for a moment, imagine this whole thing is your watermelon. There's a watermelon you purchased. And what's happening? Somebody is asking, hey, your friend comes to your house and says, buddy, just give me a small piece of watermelon. What you do? You're cutting it and you're giving it to your friend. You're giving it to your friend. So what is that? It is called slicing a watermelon. So we're saying here, this matrix is acting like a watermelon and we are slicing it and extracting a part of it is in a slightly friendly way. Everybody with me, guys? Quick, please. One more time. Sorry about that. Okay. Now let's see what else we have, guys. Okay. Now take a look at this, guys. Let's see what's happening here. Increasing the complexity a little bit syntactically. So what this is doing is you're specifically asking, give me the first row, give me the fourth row, give me the 10th row. Remember, Python is following zero-based index. So what it is doing? First array, the fourth array, and the 10th array. So what is slightly different here is, when we were slicing and dicing here, we were only using one square bracket. But now it looks like we're using two square brackets. For x and a single bracket, we're giving a list object. When you give a list object, what it's doing is it's performing row-wise operation. It's extracting the rows, is what is happening. Okay, let's see if you have more of them. Now take a look at this. You want the same thing. The first one, the fourth one, and the 10th one, and there is a 2. 2 means third column. So let's see what happens now. There it is, 2, 32, and 92, which means, come back here, do a little bit of cleanup. Okay, so there is a complete one. First, what we are doing is, we're saying extract the first one, fourth one, and the 10th one, which means, let's say, here's the first one, 2, 3, 4. Here's the fourth one, and let's say the last one, for the sake of simplicity, we'll call this as the 10th one. Then what you're doing is you're asking them, give me the second. So 2 means 3. So what is that one? Let's say, choose this one. 2 means 3. So in this one, pick up the third object, pick up the third object, pick up the third object. A group of objects. Okay, how? With one line of code, with one word, with one letter. That's a very, very powerful thing, guys. So if you're slightly into programming and thing, you'll kind of you can very much appreciate the power of that. But you don't have to worry about that aspect of it, about the appreciation. More precisely, you need to get comfortable with this kind of thinking. Let's take another example. One more time, 039 and 093. Now we are on the right side, we're giving a group of columns, not one column, but a group of columns. On the left hand side, we're saying I want these rows. On the right hand side, we need these columns. So let's see what that means. Come here, undo this one. The pink ones remain the same. But in the first row, extract 0 means in the first row, the first one, which will end up being this one. Okay. Then in the second row, give me the 10th one, which will end up being this one. Then in the next row, which is 9 is 10th row, you want the fourth one. Fourth one will be this one. Notice that 0, 39, and 93, isn't it, guys? 0, 39. I'm sorry. Here we're assuming this as the 10th one. If you scroll down, there you go, 93. Everybody with me, guys? Quick yes, please. Okay, so again, if you have a little bit of idea writing a little bit of for loops, nested for loops, and you want to extract this kind of numbers in Java and .NET, that will be some good effort. You will do some good thinking. In other words, you will do some complex thinking. What is this? You're able to extract some randomly. You give some random numbers there, you're able to extract the numbers you want. That is really a beauty. That is what is the power of Numpy, guys. Okay, some of you guys are asking me to repeat it, guys. So just bear with me. I want you to pay a little bit more attention so that I can cover more aspects of it and try to get to the meat of it, guys. By the end of this week, I will try to provide you some notes, guys. So just have a little faith in me. Give me a little bit of time. It's been a little busy at work, so that's why I'm taking a little bit of time preparing, guys. So be a little bit patient. Thank you, guys. I appreciate that. Okay. So now, gentlemen, ladies, increasing the complexity again. I'm going to take you to a slightly higher one. It's not complex, but let's take another example. This is called Boolean Indexing. Let's see what this is. X is greater than 50. We're calling that as a Boolean. That is going to act like a filter. This is called a filter. And here is X. What it is. We're getting all trues and false. Wherever, what it is doing is it is going back here. If you come back here, let's say do a little bit of cleanup. And this is our complete set. This is sitting inside this two-dimensional. Inside one, let's say pink one. That's two-dimensional is what is happening, guys. Now what we are doing here is when we give a filter like this, what it is doing is it is picking up each cup. Oops, let's say come here. Choose this one. Is it greater than 50? No, false. Greater than 50? False, false. Up to where? To here. 50, is it greater than 50? Yes, yes. So all these are yes, yes, yes. All those which are where the filter is not getting satisfied is false, false, false. Ideally, this kind of a filter, what we do, take a look at this. You pass it to itself, which is a double dimensional array. And now notice what you get is you're only extracting those items which are where that condition is getting satisfied. This is called Boolean indexing. Academically, we call this as Boolean indexing, guys. What we are doing, pardon me, sorry about that. Okay, so that is called Boolean indexing, and we are just extracting the items from that one. Everybody with me, guys? Can you give me a quick yes? Okay, good, guys. Looks like some of you seem to be appreciating the teaching. I appreciate that. Please put in the feedback also. That will also be appreciated, guys. Thank you again. That's sportsmanship. Keep that positive spirit. Here and there, if I seem to be missing something or going a little fast here, bear with me, guys. There are a lot of people. It will be helpful if I cover a few more things rather than repeat the same thing again and again. There are both advantages and disadvantages in it, but for the sake of spirit, we'll exhibit a little bit of sportsmanship there. Okay, guys, I hope you all understand that. Thank you, guys. Thank you. Okay, let's move a little ahead. Now take a look at this, guys. Increasing the complexity one more time. Three-dimensional. An array of arrays. Got a bunch of arrays. Looks like roughly about maybe 10 of them. Let's see what that looks like. Here. So it's a three-dimensional. Okay, now let's see what we got here. Now take a look at this, guys. X of 0. So that is okay. So now take a look at this, guys. My bad. Sorry about that. I'm going to struggle a little bit trying to simplify this one. It's a simple one, but I'm thinking. So now take a look at X again. Notice what happens. The first one has become 100. In other words, what we are trying to do, what we have done here is we are modifying a three-dimensional array. In other words, what it means is our arrays are also modifiable. What did we have? We had 1. What was 1? We had modified it. What did we do? We just use that kind of indexing. Okay, it's indirectly saying go to the first tray. In that first tray, get me the first tray. In that first tray, get me the first cup. So it's like saying, okay, let's give a quick try here and see if we can visualize this, guys. Come here. Put this here. So imagine a big one for the sake of simplicity. In that one, let's say, how about this one? Let's say, let's give this this one, a green tray. In that one, let's put a blue one. Okay, blue, a blue, and a blue. This is 3 dimensions. Now what's happening is, let's take this one. This is 1. This is 2. This is 3. So when we say, come back here, 0, 0, 0, 0, 0, 0. Sorry about that. When we say 0, 0, let's see if you're able to understand, visualize this and extract it. Go to what it is doing is, visualize, it doesn't come to the pink one. It goes to the green one. It goes to the first tray. And what it is doing, then the second 0 maps to the blue one. And the third 0 maps to this one. What's it doing? It's picking up 1. Picks up 1. What is it doing? And there we're putting 100. Everybody catching it, guys? Can you give me a quick yes? That is how it is working. So let's see. YouTube video. You can also check in the YouTube video. There is Kranti a message which might help you. First row, first column, first cup, replace 100. There is Manoj. Another, if that helps you, you can also think of it. First row, first column, and first cup is what we say. saying, guys. Okay, so that's what I'm visualizing. So in other words, let's say one more time for sake of simplicity, you can visualize this as another green tray, and let's say come back here, 3 blue trays, and visualize your cups there. Just do the mapping. You can also transpose them. You can transpose them and put your own visualization. You don't have to exactly follow my visualization. I'm trying my best to put it in a simple way, but even if you transpose this, you come up with your own visualization. If you put a little bit of effort, you'll be able to visualize that. Try doing that, guys. If you're able to visualize that, then you're into that array-oriented thinking. Once you get a grasp of array-oriented thinking, gentlemen, ladies, it will be very, very helpful. You will see, you will notice, you will become a very powerful thinker, is what you will realize. That's what that is. So let's see what else we have. Okay. Okay, a couple of things, and I'll try to wrap this up here for today. And let's see what's happening here. Now take a look at this, guys. Before we do this, let's go back here. This is our X. After we modified, we plugged in 100 there. That's how our three-dimensional array is looking. Now we'll do this one. What is this doing? It's like saying, go to every tray, pick up the first row, pick up the first cup in every tray and plug in 99. So take a look at X. What's happening? It goes to every green tray. It's picking up the second blue, which is going to be second blue, and pick up the second cup there. 99. Repeat that there. Repeat that there. So now, if we come back here, let's say do a little bit of cleanup here. So one more time. This is the green tray. There is a green tray. There's a green tray. And let's quickly put the second, here is the second tray, second tray, second tray. Now what do? Pick up the second cup, and the second cup. That is exactly what is happening. So notice one more time, take a look at your results. So there it is. Go to every green tray. In other words, more precisely, this is telling go to every green tray, pick up the second one, which is every second blue tray, and pick up every second cup. That is what is happening. Everybody with me, guys. Quick yes, please. Okay. Then last one for today. Let's see what we have. Now we are saying go to every green tray. I'm sorry. Go to the first green tray, pick up all those, pick up all the blue rows and all the cups and plug in minus 888. So let's see how that looks. So copy that one. Here, scroll down here. And now take a look at X. Shift enter. Notice in the green tray. In other words, if we come back now here, the first zero says, hey, go to the first green tray. Then what are we doing? Pick up that blue cup, this blue tray, pick up every cup. Start filling it with minus 888. Everybody catching it, guys? Quick yes, please. Good. Okay. So let's see what else we have here. Okay. It's a little bit of array-oriented thinking. Okay. I think we are at a logical point. What we'll do tomorrow is I will dig a little bit into different objects called tuple sets, and probably I'll touch a little bit of data frame if time permits. That is the next level. More different kinds of things, and this kind of array-oriented thinking will also be helpful, guys. These kind of concepts will apply a lot of other kinds of objects. You will see the use of them, guys. Okay. So now I want to give a few minutes for open the platform for a few questions and things like that, guys. Please type in your questions. Replaces the values and the position of determines which value should be located in a row and column. That is true, Manoj. Enter examples. Very good, Priya. Keep it up. Tuples tomorrow. Swarna. Sushma, we have to cover a lot more topics, but we'll cover this kind of concepts again, Sushma, so don't worry. Array module, right? Is it different from... No. We don't have a built-in array module in Python, Nitin. The arrays are there only in NumPys. We have a list in Python. We don't have an array. Useful for arrays. Yeah. One of the major advantage of NumPy is this arrays and matrices. We can use full. You can use full function, but you need to give a thought because full is filling up everything with the same value. Can we cover one character to convert one to int? Yes, you can convert one to int. Okay. So if I don't know if you're asking, this is probably a simple question for me. So here is one. Let's say is one. This is a string. This is textual data. If you want to convert to int, you say int is like a function, or there is one. Okay. If that was the question you asked, that is that, guys. Algorithms probably next week, guys. After I touch a little bit of object orientation, maybe on Friday, maybe next Monday, I will be starting a little bit of machine learning and we'll dig a little bit deep into it. NP array, NP array and matrix. Array, you're generally creating one-dimensional array. Matrix directly creates a two-dimension. You can also use an array to create two-dimension, but matrix starts with a two-dimension. When will OpenCV? Oh, the next week I'll focus on a little bit of machine learning. That next week I'll focus on OpenCV. That next week I'll focus on NLPs. That's my plan, guys. Difference between Python, C++, JavaScript. Python is high-level language, guys. C++ is a very low-level language. We write a lot of code, if that is what you're asking. SQL, no, guys. I will not be able to cover SQL because this is more focused on machine learning and the AI and the data science part of it. Very good. Keep it up. Somebody is giving some good comments there. Correlation coefficients, we'll talk about that next week when I get into the world of machine learning. Pandas contains data frames. Pandas data frames are similar to NumPys. They will borrow a lot of concepts from NumPy, and we'll talk about them, guys. They are the next major big ones, milestones, and they're the breadth of their very, very important component. Tuples again, maybe tomorrow I'll be touching it. The comments are going a little fast, little quick here, not giving me time to read them completely, so I'm just taking a little time, so be a little patient. Import array. Feedback form, I think Mansa will take care of that, guys. Data science from scratch, hands-on machine learning are a couple of books, guys. I repeat, data science from scratch and the hands-on machine learning from O'Reilly Publications especially. I like those books. Pandas, yes, I'll be covering Pandas, Ashok. That is in a probably day or two. You can convert characters into arrays. Oh, I see what you mean. That's a tough question, buddy. Whoever is asking that, I couldn't read your name. The short answer is yes, but I may just need to do a little bit of playing around. Let me not play around now. I'll confuse others. The short answer is definitely a yes. Good question there. Hemant. Very good. Visualization, I may not have time. Visualization, we'll touch a little bit of visualization in the machine learning aspect of it. Voice is great. Good, buddy. Good, guys. Sportsmanship there. Keep it up. Correlation. Thank you, guys. Coaching center. Yeah, Naresh IT, guys. Naresh IT asked for Naveen Pathuru. That's my name. I'll be starting some batches maybe next month. If you're interested, please coordinate Naresh IT. Folks. Cover concatenate. Concatenate is joining, Vinod. Joining two of the two strings, textual data. Is NumPy only useful for arrays? Oh, no. NumPy has a lot of other scientific and mathematical functions. And we cannot obviously cover anything. But generally what happens is the high-level functions. We tend to use the high-level functions. The high-level functions do a lot of low-level stuff, guys. And The low level stuff is where a lot of these mathematical calculations, array oriented operations are automatically happening. Okay. Thank you again for those good comments, guys. I appreciate that. Yes, notes, just give me 1 or 2 days or maybe till Friday, guys. At the end of the year, we are having a lot of work we are not finding. So I will try to provide you the notes for sure. AI, the machine learning, the deep learning is what the AI part of it is. Those are very, very vast topics, but I'll give you a quick touch so that you have a good idea. If you do a little bit of practice, you can definitely, um, you know, it will be helpful for your job search and things like that. Okay. Fintech, you're teaching fintech in finance. Okay. I think if you're asking if we are into fintech, the financial world and things like that, the concepts are also useful. If you go into the finance world, the stock market world and things like that, the concept is same. If you learn the ambassador car, how to drive an ambassador car, you can drive a BMW and a Benz. What is important is you learn to drive how to drive a car. Okay. So if you know the concepts, you can use in a financial domain, you can use a healthcare domain, you can use in a telecom domain or any other domain, guys. As data scientists, as AI professionals, that is what you will be expected. All you will be expected is you know the concept. The data will be different, but the concept is same. Very good. Snehita. Good one there. Can pandas deal with 20 million? Short answer is yes. Who's that? Ravi. Short answer is yes. There are some optimization techniques we can use. Rashmi, thank you. Keep it up. Data science, SQL and Python. Ah, again, just like we are extracting, we are doing the slicing and dicing with Numpy using an array-oriented language, we can also use SQL to do the slicing and dicing. But array, what you do in one word, in one line, in one letter, using an array-oriented, in SQL, you can do similar kind of things, not everything, but what happens is, in SQL, you'll end up writing one line, 2 lines, you'll have to think in terms of joins and things like that. So SQL is a bit more complex. You can do it. You can also give SQL-like things. We may not have time to do the SQL part of it, guys. MongoDB is a NoSQL database and things like that. That is not part of this one, so we'll not be touching that. Mean stack is also different. That's more of a what do we say? The UI and things like that, guys. This is more of a machine learning. This is where the innovation and creativity is, guys. PHP, Django, all these are UIs. How about this one, guys? Think of UI. UI programming is like doing the fielding and the wicket keeping. The machine learning, the deep learning is the innovation and the creativity part. This is like the batting and the bowling of the cricket. This is where everybody is focusing today. All the companies. TensorFlow is deep learning, guys. Um, Material, as I said, we are working on it, guys. By the end of this week, we'll start providing you. Good, guys. Thank you for your love, your like. It's all the positive spirit is very positively contagious, especially in today's world with all the COVID and things like that. That positiveness is very good. Keep it up. But for today, allow me to sign off here. I will leave a few minutes for feedback for Mansa. Any non-technical questions, she will be able to handle it, guys. Thank you again for your positive comments. Let's keep up that positive spirit, and hopefully I will add a little bit more value in the coming up days and try to be of help to you guys. Thank you. Thank you again, guys. Signing off for today. You guys take care, and bye for now, guys. I will leave it to Mansa now. Thank you again. Bye for now. Thank you. Stay safe. Keep learning.
I hope everything is clear. I have already posted the feedback link in the chat box. Please check it. Bharat Kumar, it's a 4-week training program. So we'll let you know the exact date soon. Thank you. Thank you all. Please fill the feedback form and your attendance will be considered only through the feedback form. So please fill it. Thank you all.